In this video, we'll talk about the quotient rule for finding the derivative of the quotient of two functions. So as with products, quotients also don't work super nicely. So I got the function x cubed again. Its derivative should be 3x squared, but I can write x cubed again as, say, x to the 10th over x to the 7th. X to the 10th has a 10x to the 9th, x to the 7th becomes 7x to the 6th in the derivative, and again, I want to figure out a way to combine these two somehow to get me back to a 3x squared at the end of the day. It's not simple, it's not easy to see at the outset what happens, but there is thankfully the quotient rule, which is a nice formula for knowing how to do this. And there are proofs for this as well, but they're not things you need to know for this course. The main things to know are how to apply these different rules to solve for the derivatives of certain functions. So what is the quotient rule? The quotient rule says the following. If I want to find the derivative of the quotient f of x over g of x, I do that by the following. It's g of x times the derivative of f minus f of x times the derivative of g all over g of x squared. Or in Newton's notation, f over g prime is g of x f prime of x minus f of x g prime of x over g of x squared. It's important to keep the order straight on these ones, because for this case you have a minus sign here in the middle, so it matters which pair you put first. For the product rule, we had of just f g prime plus g times f prime. That was a plus sign, so it didn't matter which of those two terms I put first, I'd get the same answer anyway. For the quotient rule though, there's a minus in there, so it matters which way you put these together. And I'll talk about my mnemonic for this with the example here. So to find the derivative of this function, it's x squared plus 1 over x to the 4th minus 2x plus 3. How are we going to find the derivative? So my mnemonic here is low d high minus high d low over the bottom squared. That's at least how I say it in my head when I'm solving this problem. It stuck with me long enough, and it gives me enough leverage to be able to solve problems like this. So what is f prime of x here? Well, low is the bottom function, x to the 4th minus 2x plus 3. D high is the derivative of the top function, which is 2x, the normal power rule there, minus high, the top function, x squared plus 1, d low, derivative of the bottom function, 4x cubed minus 2, over the bottom squared, take the function on the bottom, x to the 4th minus 2x plus 3, and then square it. You could leave it like this, or you could expand, factor, and cancel things out, get an expression like that. That's using the quotient rule to find the derivative functions that are quotients. It's important to make sure you keep this rule straight and remember the order which the terms go, because the order here matters as it's a difference and not a sum. And so it's important to know which term goes first when using the quotient rule to find these derivatives, and that's how you do it.